Tonight, you're about to experience something quietly unsettling. Because the Milky Way, the vast galaxy that holds every star you've ever seen, every planet, every sunrise, every moment of your life, is both unimaginably large and almost nothing at all. And the strange part is, both of those statements are completely true. If you've ever looked up at the night sky and noticed that faint glowing band stretching across the darkness, you were looking at the edge of something enormous. A structure so wide that even light, the fastest thing in the universe, needs 100,000 years just to cross from one side to the other. And yet, by the time we reach the end of this journey, that same galaxy will feel smaller than a grain of dust. This is the Milky Way paradox. And once you see it clearly, it's very hard to unsee. Here on Valoran's Sleepy Space Mysteries, we explore questions like this slowly, gently, letting each layer of the universe unfold in a way that you can simply listen to without needing to see anything at all. If you've ever listened to our story about how the universe might not have an edge, you already know how strange things can become when scale starts to stretch beyond human intuition. Tonight, we go even further. We're going to begin where you are right now inside this galaxy and gradually drift outward, past neighboring galaxies, beyond clusters, into structures so vast they almost stop feeling real. And somewhere along the way, the Milky Way will begin to shrink, not in size, but in importance. So before we begin drifting outward, take a moment to settle in. If you enjoy slow cosmic journeys like this, you can subscribe, leave a quiet like, and maybe turn on the bell so you don't miss future explorations. Some listeners also choose to support the channel as members, and if you'd like, you can share where you're listening from tonight. It's always fascinating to see how far these stories travel. Now, let's begin exactly where you are, inside something that feels infinite, but isn't. If we're going to understand why the Milky Way eventually begins to feel small, we first need to feel just how enormous it truly is. And that means starting from where you are right now and slowly expanding outward, step by step, until the familiar begins to dissolve into something much larger. Because right now, without realizing it, you're sitting inside a structure so vast that even trying to imagine it properly already stretches the limits of human perception. The Milky Way is not just a collection of stars scattered randomly through space. It is a vast, rotating system, a kind of cosmic city made of light. It stretches about 100,000 light years from one side to the other, which means that if you could somehow travel at the speed of light itself, moving faster than anything we know, it would still take you 100,000 years just to cross it. Not to explore it, not to map it, just to go from one edge to the other in a straight line. And within that immense span, there are not thousands, not millions, but somewhere between 100 billion and 400 billion stars, each one potentially hosting planets, moons, and entire systems of its own. And among all of those stars, there is one small, unremarkable star that we call the Sun. It sits far from the center of the galaxy, about 26,000 light years away, tucked quietly inside a minor spiral arm known as the Orion Spur. This is not a crowded or chaotic region. It is relatively calm, a kind of galactic suburb where stars are spaced far enough apart that catastrophic events like nearby supernovae are rare. And that quiet stability may be the reason you are here at all listening to this. Because in more crowded regions of the galaxy, life might never have had the chance to survive long enough to evolve. If you were able to step far enough away to see the Milky Way from the outside, you would notice its elegant spiral shape. Long, curved arms stretching outward from a bright central bulge, all slowly rotating over hundreds of millions of years. It would look peaceful, almost delicate, but inside, it is a place of constant motion. Stars orbit the center at incredible speeds, entire systems drifting through space in slow, silent arcs. Even our own sun is moving, carrying Earth with it at about 200 kilometers per second, completing one full orbit around the galaxy roughly every 230 million years. Which means that since the time of the dinosaurs, we haven't even completed a full trip around the Milky Way yet. Now here's something that begins to shift perspective slightly. When people hear about galaxies, they often imagine that most of them are like the Milky Way, a vast, bright, filled with hundreds of billions of stars. But that assumption is not quite true. In fact, most galaxies in the universe are much smaller. Many are what astronomers call dwarf galaxies, containing only a few billion stars, sometimes even fewer. Compared to those, the Milky Way is enormous. Not just large, but exceptional. If you were to randomly select galaxies from across the universe, the vast majority would be smaller than ours. The Milky Way actually sits comfortably in the upper tier among the larger galaxies that exist. So in this first layer of perspective, the Milky Way feels dominant. It is not average. It is not insignificant. It is one of the giants, a massive spiral system surrounded by smaller companions. And those companions are all around us. Some of them are visible even without a telescope, though most people don't realize what they're looking at. The large and small Magellanic Clouds, for example, appear as faint patches of light in the southern sky. For most of human history, they were simply mysterious glowing smudges. But now we understand that they are entire galaxies, smaller than the Milky Way, but still containing billions of stars, slowly orbiting our galaxy like distant satellites. And then there is Andromeda, the nearest large galaxy to us. It sits about 2.5 million light-years away, which already sounds like an unimaginable distance. And yet, in cosmic terms, it is practically next door. Andromeda is even larger than the Milky Way, containing perhaps 1 trillion stars. It is slowly moving toward us, and in about 4.5 billion years, the two galaxies will merge. Not in a violent explosion, but in a slow, graceful blending. Stars will pass by each other across vast distances, rarely colliding, as the two structures gradually reshape into something new. So even at this stage, something subtle begins to emerge. The Milky Way is not alone. It is part of a small community, a gathering of galaxies bound together by gravity. This collection is known as the Local Group, and it contains around 50 galaxies in total. Most of them are small, faint, easily overlooked. But the Milky Way and Andromeda dominate this group, acting like the two largest presences in a quiet cosmic neighborhood. And this is where the first quiet question begins to form. If the Milky Way already feels so vast, so complete, so overwhelmingly large, Why does it need neighbors at all? And what lies beyond them? As that question begins to settle in your mind, the sense of scale starts to shift again, almost imperceptibly at first. Because the local group, this small gathering of around 50 galaxies, might sound impressive, but in reality, it is only the beginning of something much larger. And the Milky Way, despite everything we've just explored, is only one member, one participant, in a structure that extends far beyond what we can intuitively grasp. The local group itself stretches across roughly 10 million light-years. Already, that number is difficult to hold on to. If traveling across the Milky Way takes 100,000 years at the speed of light, then crossing the local group would take 100 times longer. 10 million years, just to move from one side of this small cosmic neighborhood to the other. And yet, even at that scale, this entire group of galaxies remains gravitationally connected, slowly interacting, drifting, and subtly influencing one another over immense periods of time. At the center of this quiet dance are the two dominant galaxies, the Milky Way and Andromeda. Around them, smaller dwarf galaxies orbit like distant companions, some bound tightly, others loosely drifting through the shared gravitational field. Over billions of years, many of these smaller galaxies will not remain separate. They will be pulled apart, stretched, and eventually absorbed, their stars becoming part of larger systems. In fact, this process is already happening. The Milky Way is currently in the process of consuming a smaller galaxy known as the Sagittarius dwarf, slowly unraveling it and incorporating its stars into its own halo. So even what feels stable is quietly changing. But here is where the next layer of the paradox begins to emerge more clearly. Because as vast as the local group feels, it is not isolated. It is not a unique cluster floating alone in space. It is just one small piece inside something far larger, something that begins to blur the boundaries of what we can meaningfully imagine. The local group is part of a much bigger structure known as the Virgo supercluster. And this is where scale begins to stretch in a way that feels almost abstract. The Virgo supercluster spans over 100 million light-years. Not 10 million, 100 million. It contains not just dozens of galaxies, but tens of thousands of them, grouped into clusters and subgroups, all connected through gravity in a vast, sprawling system. Somewhere within this immense structure lies the Virgo cluster itself, a dense region containing over 1,000 galaxies, many of them larger and more massive than the Milky Way. And suddenly, the perspective shifts again, because within the Virgo supercluster, the local group is no longer a central feature. It is not dominant. It is not even particularly noticeable. It becomes just one small cluster among many, a minor detail in a much larger arrangement. If the Virgo supercluster were scaled down to the size of a large city, the local group would be like a single neighborhood, and the Milky Way would be just one building within it. Still large on its own, still complex, but no longer special in the broader context. And yet, even this is not the full picture, because in 2014, astronomers realized something even more unsettling. The Virgo supercluster itself is not an independent structure. It is part of something even larger, something so vast that it required a new way of thinking about cosmic organization. This structure is known as Laniakea, a name that means immeasurable heaven. And that name is not an exaggeration. Laniakea spans roughly 500 million light-years and contains around 100,000 galaxies. It is not just a cluster of galaxies or even a cluster of clusters. It is a supercluster of superclusters. Within it, entire galaxy groups, including our own, are not sitting still. They are all slowly moving, flowing through space toward a common region, drawn by gravity toward something known as the Great Attractor. This motion is subtle, but it is real. The Milky Way itself is moving at hundreds of kilometers per second, not just orbiting within its own structure, but drifting along with everything around it toward a destination we cannot directly see. And now the scale becomes even harder to hold on to. Because if you were to shrink the Milky Way down to the size of a grain of sand, then Laniakea would still be large enough to fill an entire room. Everything we have discussed so far, every star, every planet, every galaxy in our local region, all compressed into something that still barely fits within a single space. And this is the moment where the Milky Way begins to feel different. It has not changed in size. It is still 100,000 light-years across. It still contains hundreds of billions of stars. But its role, its importance begins to fade slightly. It becomes one component in a structure so large that individual galaxies start to lose their identity. And quietly, another question begins to form. If even Laniakea, something that vast, is still not the end, then how far does this structure really go? And where does it finally stop? As that question lingers, something subtle begins to change in how we perceive space itself. Because up to this point, everything has still felt structured, organized, almost layered in a way that the mind can follow. Galaxies form groups, groups form clusters, clusters form superclusters. It feels like a hierarchy, something with levels that stack neatly on top of each other. But as we move beyond Laniakea, that sense of order begins to dissolve into something far stranger. When astronomers started mapping the positions of galaxies on the largest possible scales, they expected to find something close to randomness, galaxies scattered more or less evenly throughout space. But that is not what they found. Instead, they discovered that galaxies are arranged in patterns of vast, intricate patterns that stretch across unimaginable distances. And these patterns form what we now call the cosmic web. The cosmic web is not a single structure like a galaxy or a cluster. It is the overall architecture of the universe itself. Galaxies are not spread out uniformly. They gather along enormous filaments, like threads stretching across space. These filaments intersect at dense nodes, where galaxy clusters form, and between them lie vast empty regions known as voids. So instead of a smooth distribution, the universe looks more like a three-dimensional web, or perhaps a sponge, with matter concentrated along thin strands and almost nothing in between. And this is where the scale becomes deeply unsettling, because these voids are not small gaps. They are enormous. Some of them stretch across hundreds of millions of light years. Others are even larger. There is one known region, often referred to as the KBC void, that spans nearly 2 billion light-years across. To put that into perspective, you could place the Milky Way side by side across that void 20,000 times and still not reach the other side. Even Laniakea, that immense structure containing 100,000 galaxies, would appear small within it. Imagine drifting into such a void. No nearby galaxies, no bright clusters, just darkness stretching in every direction. The nearest major structures would be so far away that even the largest galaxies would appear as faint, barely visible smudges. In that kind of emptiness, the idea of a galaxy itself begins to feel insignificant, like a distant memory rather than a dominant presence. And yet, surrounding these voids are the filaments, the threads of the cosmic web, where galaxies gather in vast chains and walls. Some of these structures are so large that they challenge our understanding of how the universe even formed. One example is the Sloan Great Wall, a structure that stretches over 1 billion light-years across and contains tens of thousands of galaxies. Not one or two clusters, but an entire sheet of galaxies, connected across distances so large that light itself takes over 1 billion years to travel from one end to the other. And again, the Milky Way finds itself somewhere within this immense network. Not at the center, not at a special intersection, just one galaxy among many, sitting quietly along a filament, part of a structure that extends far beyond anything we can directly observe in a single view. What makes this even more fascinating is that these patterns did not form randomly. They emerged from the earliest moments of the universe. Tiny fluctuations in density, almost unimaginably small differences in how matter was distributed shortly after the beginning, were slowly amplified over billions of years by gravity. Regions that were slightly denser attracted more matter, becoming filaments and clusters. Regions that were slightly less dense lost matter, becoming voids. And over time, this delicate imbalance grew into the vast cosmic web we see today. But there is something even deeper beneath this structure, something invisible that shapes everything. The cosmic web is not primarily made of stars or galaxies. Those are just the visible parts. The true framework is dark matter, an unseen form of matter that does not emit light, but exerts gravity. It forms the scaffolding of the universe, guiding where galaxies form and how they cluster together. In a sense, what we see, all the stars and galaxies, are just small highlights tracing out a much larger, invisible structure. And this realization adds another layer to the paradox. Because now, the Milky Way is not just one galaxy among billions. It is also just a small concentration of visible matter embedded within a much larger, invisible network. Its position, its motion, even its formation, are all influenced by structures we cannot directly see. So as we continue to drift outward, the Milky Way fades further into the background. Not because it becomes smaller, but because the context around it keeps expanding. Each new layer makes the previous one feel less central, less defining. And now, as the cosmic web stretches out in every direction, another question quietly emerges. If this web connects everything we can see, what happens at the very edge of it? And is there even an edge at all? As that question settles in, whether there is an edge to this immense structure, the answer begins to unfold in a way that is both subtle and deeply unsettling. Because the cosmic web, as vast as it is, does not behave like an object with a clear boundary. It does not simply end the way a galaxy ends, or even the way a supercluster fades into surrounding space. Instead, it continues, stretching outward in all directions, gradually thinning, connecting, dissolving into regions we can barely observe. And the deeper we look, the more it becomes clear that what we are seeing is not the limit of the universe, but only the limit of what we can detect. This is where we encounter the idea of the observable universe. Everything we have discussed so far, the Milky Way, the local group Laniakea, the cosmic web, all of it exists within a region defined not by physical boundaries but by time. Light travels at a finite speed, and the universe itself has a finite age, about 13.8 billion years. That means there is a maximum distance from which light has had enough time to reach us. Beyond that distance, there may be galaxies, structures, entire regions of space, but their light simply has not arrived yet. But even this idea hides something unexpected, because the observable universe is not just 13.8 billion light-years across. Due to the expansion of space itself, the most distant regions we can observe are now much farther away than that. As light traveled toward us over billions of years, the space between us and its source continued to stretch. So by the time that light finally reaches us, the source may now be tens of billions of light-years away. When all of this is taken into account, the observable universe is about 93 billion light-years across. And within that enormous volume, astronomers estimate there are around 2 trillion galaxies. 2 trillion. Each one containing anywhere from millions to trillions of stars. Each one potentially hosting planets, systems, maybe even life. And among all of them, the Milky Way is just one. Not central, not uniquely large, just one galaxy among an almost unimaginable number of others. At this point, the paradox becomes impossible to ignore, because earlier the Milky Way felt enormous. It dominated its surroundings. It stood out among smaller galaxies. But now, placed within the observable universe, it becomes something else entirely. It becomes a single data point, one instance among trillions. If you tried to represent every galaxy as a grain of sand, you would need enough sand to fill multiple Olympic-sized swimming pools. And somewhere in that vast collection, indistinguishable from the rest, would be the Milky Way. And yet, even now, we are still not at the true edge, because the observable universe is only what we can see. It is limited by time and light, not by actual physical boundaries. Beyond it, the universe almost certainly continues. It may extend far beyond what we can measure. It may even be infinite. And if that is true, then everything we have described so far, every galaxy, every cluster, every filament, becomes just a tiny fraction of something much larger. And in an infinite universe, the Milky Way does not just become small. It becomes almost mathematically insignificant, a vanishing fraction of something without end. This is where the mind begins to struggle, not because the concepts are complex, but because the scale removes any familiar reference point. There is no comparison that truly captures it, no analogy that fully holds. It is not just that the Milky Way is small compared to the universe. It is that the idea of size itself begins to lose meaning at these scales. But there is something else, something quieter, that emerges from this realization. Because while the Milky Way may not be special in size or position, it is still the place where you are. It is the only galaxy we have ever known from the inside. Every memory, every thought, every moment of awareness has happened within this single structure. And that gives it a kind of significance that scale alone cannot erase. Still, the universe does not pause for perspective. Beyond the observable horizon, space continues to expand. Galaxies drift farther apart. Light from distant regions will never reach us. Over unimaginable spans of time, more and more of the universe will slip beyond our ability to observe. The night sky, far in the future, will grow darker, emptier, as distant galaxies fade from view. And the Milky Way, along with its neighbors, will remain as one small island of light in an ever-expanding sea of darkness. So now, as we reach the edge of what we can see, another question begins to form, softer this time, almost reflective. If the universe is this vast, this layered, this endlessly expanding, what does that make our place within it? And does anything, anywhere, truly sit at the center of it all? And as that question gently lingers, whether anything in the universe truly sits at the center, the answer, perhaps surprisingly, is no. Or at least, not in the way we instinctively imagine. Because one of the most profound realizations in modern astronomy is that the universe does not have a center in the traditional sense. There is no single point from which everything expands outward. Instead, expansion happens everywhere, all at once. Every galaxy sees other galaxies moving away from it, no matter where it is located. Which means that from our perspective, it can feel as though we are at the center, but so could any other galaxy anywhere else. This idea can feel disorienting at first, because as humans, we naturally look for a reference point, a place to anchor our understanding. But the universe does not offer one. It is not built around a central location. It is not organized with a focal point. It simply exists, expanding, evolving, stretching in all directions simultaneously. And within that expansion, the Milky Way is not positioned at a special location. It is not near the center, because there is no center to be near. It is simply somewhere, one point among countless others. And yet, despite this lack of a cosmic center, something interesting begins to emerge when we reflect on where we actually are. Because while the Milky Way is not central in a physical sense, it becomes central in a different way. It becomes the center of our experience. Every observation we make, every measurement, every map of the universe is constructed from this one location. In that sense, the Milky Way is the center of everything we can know, even if it is not the center of everything that exists. But even this perspective begins to soften as we consider how much of the universe remains beyond our reach. The observable universe sets a boundary not because space ends there, but because information cannot travel faster than light. There may be regions of the universe so distant that their light will never reach us, no matter how long we wait. Entire galaxies, entire structures, existing completely beyond our awareness. Not hidden, not obscured, simply too far away for their signals to ever arrive. And this introduces a quiet kind of isolation, because even if the universe is filled with galaxies, even if life exists elsewhere, even if intelligence has arisen countless times, the distances between these places are so vast that connection may never happen. Signals would take millions, sometimes billions of years to travel between galaxies. Civilizations could rise and fall long before their existence is ever known elsewhere. The universe may be full and yet feel completely silent. This is part of what makes the Milky Way feel both significant and insignificant at the same time. It is vast enough to contain hundreds of billions of stars, yet small enough to be lost among trillions of galaxies. It is complex enough to give rise to life, yet ordinary enough to blend into the background of the cosmic web. It is not unique, but it is also not replaceable, because it is the only place we have ever been. And perhaps that is where the paradox finds its quiet balance. Because the Milky Way does not need to be the largest structure to matter. It does not need to sit at the center to be meaningful. Its significance does not come from its size or its position, but from the fact that within it, awareness exists. Within it, something has emerged that can look outward, can ask questions, can try to understand the very structure it is part of. And that changes the perspective slightly, because instead of asking how large the Milky Way is compared to everything else, we begin to ask something else. We begin to ask how something so small, in such a vast universe, can contain the ability to comprehend that vastness at all. And that question does not have a simple answer, but it gently brings us back, not to the center of the universe, but to the center of experience, to this one galaxy, this one quiet region, this one moment of awareness drifting through space. So as the scale of everything stretches outward, becoming almost impossible to hold in the mind, the Milky Way settles into a different kind of role. Not the largest, not the most important, but the most immediate. The place where the universe becomes something that can be noticed, something that can be felt, something that can be slowly understood. And maybe, in a universe without a center, that is the closest thing to one that truly exists. Now, as we gently leave behind this closer view of the Milky Way and everything around it, we will begin to explore something even deeper in the next part. Not just how large the universe is, but how that scale reshapes the way we think about existence itself. If you're still here, still drifting through this quiet journey, you can leave a simple 1 in the comments. It's a small signal, but a meaningful one, showing that you've made it this far. And when you're ready, we'll continue even further. As we move into this next part of the journey, something begins to shift, not just in what we're looking at, but in how we're able to understand it. Because up to now, even the largest structures still had some sense of familiarity. Galaxies, clusters, superclusters, they could still be imagined as objects, as places. But as we go further, scale stops behaving like something we can visualize, and starts becoming something we can only feel. And it begins with motion, not the motion of planets around stars or stars around galaxies, but something much larger. Entire galaxies, including the Milky Way, are not simply sitting in space. They are moving, drifting, carried along by gravitational currents that span hundreds of millions of light years. And this movement is not random. It has direction. It has flow, as if space itself contains slow, invisible rivers guiding galaxies toward regions of greater mass. Astronomers first noticed this in the 1970s, when they began measuring the motion of galaxies relative to the expanding universe. What they found was unexpected. The Milky Way, along with many nearby galaxies, is moving in a particular direction at about 600 kilometers per second. That's more than 2 million kilometers per hour. And this motion cannot be explained by expansion alone. Something is pulling us. This pull leads toward a region known as the Great Attractor. And even the name carries a kind of quiet mystery, because for a long time no one could see what was there. The region lies behind a dense part of the Milky Way, where dust and gas block our view. It was as if something enormous was hidden behind a curtain, exerting influence without revealing itself. Over time, using different kinds of observations, X-rays, infrared light, radio waves, astronomers began to piece together what might be there. What they found was not a single object, but a massive concentration of galaxies, including a cluster known as the Norma cluster. But even that was not enough to explain the full motion. There had to be something larger, something even more massive, exerting its influence across an enormous region of space. And that realization leads to something even more unsettling. Because the Great Attractor is not the final destination either. Beyond it lies an even larger structure known as the Shapley supercluster, one of the most massive known concentrations of galaxies in the nearby universe. It contains thousands of galaxies and an immense amount of mass. And it appears that not only are we moving toward the Great Attractor, but the Great Attractor itself may be moving toward something even farther away. So now, instead of thinking of the universe as static, or even slowly expanding, we begin to see it as something dynamic. A vast network of motion, where entire regions are flowing toward one another across incomprehensible distances. The Milky Way is not just orbiting within its own galaxy. It is being carried along in a much larger current, drifting through the cosmic web. And this changes something fundamental, because it means that even our position is not fixed. We are not anchored. We are part of a continuous movement, shaped by forces that extend far beyond anything we can directly observe. The ground beneath us, the stars above us, even the galaxy we belong to, are all part of a slow, silent migration. And yet, this motion is so gradual, so vast in scale, that we never feel it. Now, as we step back from this motion, another realization begins to emerge. Because if galaxies are flowing toward certain regions, that implies something about how matter is distributed on the largest scales. It suggests that space is not uniform, that there are regions of greater density and regions of emptiness, shaping the movement of everything within them. And this brings us back to the cosmic web, but now with a deeper understanding. The filaments are not just structures where galaxies happen to be. They are pathways of motion, channels through which matter flows. The nodes, the dense clusters, are like gathering points where matter accumulates over billions of years. And the voids, those vast empty regions, are not simply empty by chance. They are the result of matter being drawn away, leaving behind enormous expanses where almost nothing remains. So the universe begins to feel less like a collection of objects and more like a process, a continuous evolution shaped by gravity, guided by invisible structures, unfolding over timescales that stretch far beyond human experience. And somewhere within this process, the Milky Way continues to drift, not at the center, not at the edge, just along one of many paths in a structure that has no obvious beginning or end. And as we begin to follow that path further, another question starts to form. If everything is moving, if everything is flowing towards something, what happens when it finally arrives? And does anything in the universe ever truly come to rest? As that question quietly unfolds, whether anything in the universe ever truly comes to rest, the answer begins to reveal something even deeper about the nature of reality itself. Because in a universe shaped by motion, expansion, and gravity, stillness is not something that naturally exists. Everything is in transition. Everything is in the process of becoming something else. And this is especially true when we begin to look not just at where galaxies are, but at how they came to be in the first place. To understand that we have to go back, not just billions of years, but to the very beginning of structure itself. There was a time when none of this existed. No galaxies, no stars, no clusters, no cosmic web. Just a nearly uniform distribution of matter spread across space in a way that was almost perfectly smooth. But not entirely smooth. There were tiny differences, almost unimaginably small variations in density. Some regions contained just slightly more matter than others, differences so subtle that they were only about 1 part in 100,000. And yet, those tiny differences were enough, because gravity, even though it is the weakest of the fundamental forces, has one unique property. It only attracts. It does not cancel out. So over time, those slightly denser regions began to pull in more matter. And as they gathered more mass, their gravitational pull increased, allowing them to attract even more. A slow, self-reinforcing process began. Dense regions became denser. Empty regions became emptier. This is how the first structures formed. At first, they were small, clouds of dark matter, invisible but massive, forming what are known as halos. These halos acted like gravitational wells, pulling in ordinary matter, hydrogen and helium gas, which then began to collapse and form the first stars. These early stars were not like the ones we see today. They were massive, short-lived, burning intensely before exploding as supernovae. And in those explosions, they created the first heavier elements, carbon, oxygen, iron, the building blocks of everything that would come later. Over time, these small structures merged. 2 halos would drift together, combining into a larger one. Then larger ones would merge again, gradually building up more massive systems. This process continued over billions of years, small becoming large, simple becoming complex. And eventually galaxies began to form, not all at once, but piece by piece, through countless mergers and interactions. The Milky Way itself was formed this way. It is not a single, unified object that appeared fully formed. It is a composite, a collection of many smaller galaxies that merged together over time. Even today, we can still see traces of this history. Streams of stars moving in unusual patterns, remnants of ancient galaxies that were pulled apart and absorbed. The halo of the Milky Way contains some of the oldest stars in existence, quiet witnesses to a time when the galaxy was still assembling itself. And this process has not stopped. Right now, as you listen, the Milky Way is still evolving. It is slowly consuming smaller galaxies, pulling them apart, integrating their stars. The Sagittarius dwarf galaxy is one example, currently being stretched and absorbed. In the distant future, even larger events will occur. The Milky Way and Andromeda will eventually collide, merging into a new, larger galaxy. Not violently, but gradually, over hundreds of millions of years. So when we ask whether anything ever comes to rest, the answer becomes clearer. It doesn't. Structures form, grow, merge, and transform. Galaxies are not permanent. They are stages in an ongoing process. Even the largest galaxies we observe today, the giant ellipticals at the centers of clusters, were built through repeated mergers over billions of years. They are not final forms, just later stages. And this adds another layer to the Milky Way paradox. Because earlier we compared its size to other galaxies, to clusters, to superclusters. But now we begin to see that size itself is not fixed. It is temporary. The Milky Way is as large as it is today because of its history, the mergers it has undergone, the matter it has accumulated. In the future, it will become something else. Larger, more diffuse, perhaps less structured. So even its current form, the spiral arms, the quiet suburb where our sun resides, is not permanent. It is a moment, a snapshot in a much longer story. And that realization shifts the perspective once again. Because now, the Milky Way is not just one galaxy among trillions. It is also one stage in an evolving universe, shaped by processes that began long before it existed and will continue long after it changes. And as we continue to expand our view, another question begins to emerge, softer now, more reflective. If everything is part of this continuous process, if galaxies form and dissolve over time, then what, if anything, in the universe is truly lasting? As that question settles gently into the background, what, if anything, truly lasts in the universe? The answer begins to unfold in a way that feels both quiet and profound. Because while galaxies change, stars are born and die, and even the largest structures slowly evolve, there is something deeper that remains consistent throughout all of it. Not a specific object, not a place, but a pattern, a set of rules, a framework that shapes everything we have been exploring. And that framework is time. Not time as we usually experience it, in days or years, but time stretched across billions, even trillions of years. Because when we look at the universe on these scales, permanence becomes relative. Something that seems stable to us, like the Milky Way, is only stable because we exist for such a short moment within it. From a larger perspective, even entire galaxies are temporary arrangements, slowly forming, evolving, and eventually fading into something else. To begin to feel this, imagine watching the Milky Way not for a few seconds, or even a lifetime, but for billions of years. At first, it might appear calm, unchanging, but gradually patterns would begin to emerge. Stars would drift along their orbits. New stars would ignite in clouds of gas. Others would explode as supernovae, scattering their material into space. Spiral arms would shift, not fixed structures, but waves of density moving through the galaxy. Over immense spans of time, the entire structure would slowly transform. And then, something even more dramatic would happen. The slow approach of Andromeda, something we mentioned earlier, would finally become visible. Over hundreds of millions of years, it would grow larger in the sky, its shape becoming clearer, its stars beginning to intermingle with ours. The two galaxies would pass through each other, not once, but multiple times, gradually losing their distinct spiral forms and merging into a single, larger galaxy. The night sky, if anyone were there to see it, would be filled with shifting streams of stars, arcs of light stretching across the darkness. And eventually, after billions more years, a new galaxy would settle into place. Likely an elliptical one, larger, older, with less active star formation. The familiar spiral structure of the Milky Way would be gone, replaced by something smoother, quieter. So even galaxies, even structures that feel eternal to us, are part of a cycle. But the story does not end there, because beyond the evolution of individual galaxies, there is another process unfolding on an even larger scale: the expansion of the universe itself. Galaxies are not just moving through space, space itself is stretching. And this expansion is not slowing down. It is accelerating. Driven by something we do not fully understand, often referred to as dark energy, the universe is gradually pulling itself apart. Over unimaginable spans of time, this will have consequences. Galaxies that are not gravitationally bound to us will drift farther and farther away. Their light will become redder, dimmer, eventually fading beyond detectability. The cosmic web, those vast filaments and clusters, will begin to thin out. Connections will stretch until they break. Regions of the universe will become isolated from one another. In the far future, the merged galaxy formed from the Milky Way and Andromeda may find itself alone, surrounded by darkness. Other galaxies will have moved so far away that their light can no longer reach it. The night sky, once filled with distant galaxies, will appear almost empty. And even then, change continues. Stars will continue to form for a time, but eventually the supply of gas will run out. Star formation will slow, then stop. Existing stars will age, expanding, cooling, and eventually fading into remnants. White dwarfs, neutron stars, black holes. Over trillions of years, even these remnants will evolve. Some will merge, others will decay. Slowly, the universe will become darker, quieter, less active. And yet, even in that distant future, something remains. The underlying structure of reality, the laws that govern motion, gravity, and energy continue to operate. The patterns that shaped the first galaxies, that built the Milky Way, that guided its evolution, are still there. Not visible as objects, but present in the behavior of everything that exists. So when we ask what truly lasts, the answer is not a thing. It is the process, the continuous unfolding of the universe, shaped by simple rules, playing out across vast scales of time and space. And within that process, the Milky Way becomes something different once again. Not just a galaxy, not just a place, but a moment in an ongoing story. A temporary arrangement of matter and energy, existing for a time, then transforming into something else. And somehow, within that moment, awareness emerged. A small region of the universe, becoming aware of itself. And that leads us gently into another question, one that feels quieter, but perhaps deeper than all the others. If the universe is constantly changing, if nothing remains the same forever, what does it mean to exist, even for a moment, within it? As that question lingers, what it truly means to exist, even briefly, inside something so vast and constantly changing, the perspective begins to soften. Because up to this point, everything we've explored has been about scale, size, distance, motion, structures so large they almost erase any sense of individuality. But now something quietly shifts. The focus moves from the outside back inward. Because existence in a universe like this is not about permanence. It is about awareness within impermanence. The Milky Way, as we've seen, is not fixed. It was built from smaller galaxies, and it will eventually merge into something larger. The stars within it are constantly being born and dying. Even the atoms that make up those stars, and everything around you, were forged in earlier generations of stars, long before the Milky Way took its current form. Nothing here is static. Everything is part of a continuous chain of transformation. And yet, within that constant change, there is a moment. Right now, a moment where matter has arranged itself in such a way that it can observe, reflect, and wonder. A moment where a small part of the universe is able to ask questions about the whole. And that is something deeply unusual, perhaps even rare, because when we look out across the observable universe, across those 2 trillion galaxies, we don't see awareness everywhere. We see stars, gas, dust, patterns of gravity and light. But awareness, the ability to perceive and understand, is something we have only ever encountered here, within this one galaxy on this one planet. And that creates a different kind of significance, not based on size, not based on position, but based on experience. Because while the Milky Way may not be central in a physical sense, it is the center of this experience. It is the place where the universe becomes something that can be known. Every observation, every measurement, every idea about the cosmos originates from within this single structure. Without it, or something like it, the universe would still exist, but it would not be observed in the way it is now. And that idea begins to reshape the paradox. Because earlier, the Milky Way felt small compared to the vastness beyond it. But now, it also feels uniquely meaningful. Not because it is large, but because it contains a perspective, point of view, a place where the universe is not just happening, but being noticed. Still, even this awareness does not stop the larger processes. As that question lingers, what it truly means to exist, even briefly, within something so vast, the answer does not arrive as a clear statement. Instead, it unfolds slowly, like everything else in the universe, revealing itself through perspective. Because to understand existence at this scale, we have to shift once more, not outward this time, but inward toward the strange relationship between awareness and the cosmos that surrounds it. Up to this point, we have looked at the Milky Way as an object, a galaxy among galaxies, a structure shaped by gravity and time. We have watched it shrink in importance as larger and larger scales emerged. But now, something unusual begins to happen. The direction of the question changes. Instead of asking how small the Milky Way is compared to the universe, we begin to ask how the universe appears from within the Milky Way, from within a single point of awareness. Because everything we have described, every galaxy, every filament, every void, exists not just physically, but also as something that can be known. And that knowing happens here, inside this galaxy, on a small planet orbiting a quiet star in an unremarkable region of the Orion Spur. The same place that, just a short while ago, felt insignificant compared to the vast structures beyond it. And yet, without this point of observation, none of those structures would be experienced at all. This is where the paradox deepens. Because the Milky Way may not be large in a cosmic sense, but it contains something rare, something that transforms its role entirely. Contains observers, not just passive matter, but systems capable of reflection, capable of asking questions about the universe itself. And that changes the meaning of scale in a subtle but profound way. Because size alone does not determine significance. A galaxy can contain hundreds of billions of stars and still remain silent. Entire clusters can exist for billions of years without ever producing a single moment of awareness. But here, in this one galaxy, something has emerged that can look outward and recognize the vastness it is part of. Something that can trace the structure of the cosmic web, imagine the expansion of space, and wonder about the limits of existence itself. And that creates a different kind of center. Not a physical center, not a point in space around which everything revolves, but a center of perspective. A place where the universe becomes something that can be experienced. And from that perspective, the Milky Way is not just another galaxy. It is the environment that makes that experience possible. But even this realization does not settle into certainty. Because as we continue to expand our understanding, we begin to see that awareness itself may not be unique to this one location. If there are trillions of galaxies, and countless stars with planets, then it is possible, perhaps even likely, that awareness has emerged elsewhere as well. Other points of perspective, scattered across the universe, each one observing from its own position, each one constructing its own understanding of reality. And yet, the distances between these points are so vast that they may never intersect. This brings us back, quietly, to the idea we touched on before, the silence of the universe. The possibility that even if awareness is common, it remains isolated. Each galaxy, each civilization, existing within its own region, separated by distances that cannot be crossed within meaningful timescales. The universe may be filled with observers and still feel empty. So the Milky Way becomes something both ordinary and unique at the same time. Ordinary, because it is one galaxy among trillions. Unique, because it is the one in which this particular perspective exists. And that dual nature mirrors the larger paradox we have been exploring from the beginning. The Milky Way is vast, yet small, significant, yet not central, part of everything, yet experienced from a single point. And now, as we approach the deeper layers of this journey, another shift begins to take place. Because the question is no longer just about size or structure or motion. It becomes something more reflective, something that moves beyond physical scale and into meaning. If the universe has no center and no final boundary, if it continues outward beyond what we can ever observe, and inward into processes that never truly stop, then perhaps the question is not where we are within it, but how we relate to it at all. And that is where the next part of this journey will take us. Not further outward, but deeper into the quiet implications of everything we've seen so far. Into the idea that the universe may not simply be something we exist within, but something we are, in some small way, part of. And as that thought begins to settle gently, without urgency, one final question emerges before we move forward. If the universe can be known from within, even in a limited way, does that change what it means for it to be infinite? Or does it simply make the mystery even deeper? As that final question settles, whether understanding the universe changes its meaning or deepens its mystery, something quiet begins to emerge. Not an answer in the usual sense, but a shift in how the question itself feels. Because throughout this journey, we've been moving outward, expanding scale, watching the Milky Way shrink in importance as larger and larger structures revealed themselves. But now, at the edge of this expansion, something unexpected happens. The mystery does not disappear. It becomes more refined, because even after everything we've explored, the Milky Way's place in the local group, within Laniakea, inside the cosmic web, across an observable universe filled with trillions of galaxies, there is still no final boundary, no edge where the questions stop. Every layer we uncover leads to another. Every answer opens into a deeper unknown. And this is where the paradox reaches its most complete form. The Milky Way is small. That much is clear. Compared to the largest structures in the universe, it is almost insignificant. But the act of realizing that, the ability to trace that scale, to follow the chain from stars to galaxies to superclusters to cosmic filaments, happens within the Milky Way itself. The awareness of insignificance exists inside the very thing being measured, and that creates a kind of quiet balance. Because the Milky Way is not important because of its size, but because of what happens within it. It is a place where the universe becomes aware of its own scale, and that awareness does not reduce the mystery. It deepens it, because now, instead of asking how big the universe is, or how small we are within it, we begin to ask something else. We begin to ask how it is possible that a structure so vast, so ancient, so far beyond any single point, can give rise to something that can reflect on it at all. And that question does not have a clear boundary either, because the deeper we look, the more we begin to see that everything we've described, galaxies, clusters, motion, time, are not separate pieces, but parts of a continuous system. The atoms in your body were formed in stars that existed long before the Milky Way reached its current shape. The elements that make up planets, oceans, even the air, were forged in processes that span billions of years and countless cosmic events. So in a very real sense, the Milky Way is not just where you are. It is what you are made from, and that realization gently dissolves the distance we've been building throughout this journey. The separation between observer and universe becomes less clear, because the same processes that shaped galaxies, that formed stars, that structured the cosmic web, are also the processes that led, eventually, to awareness itself. Which means that when we look out into the universe, we are not just observing something external. We are, in a very quiet way, observing a larger version of the same process that created us. And that brings the journey full circle, because at the beginning, the Milky Way felt like everything. A vast, complete structure containing all that exists. Then it became smaller, less central, just one part of something much larger. And now, at the end of this part, it becomes something else entirely. Not everything, not nothing, but a bridge. A place where the universe becomes something that can be experienced, something that can be understood, even if only partially. A point where scale, time, and structure converge into a single perspective. And that perspective is fleeting, because like everything else, it exists for a limited time. Civilizations rise and fall. Stars evolve. Galaxies change. The Milky Way itself will not remain as it is. But for this moment, in this brief window of cosmic time, there is awareness. There is the ability to ask questions, to explore, to imagine what lies beyond what we can see. And perhaps that is enough, not to solve the mystery, but to become part of it. So as we gently transition into the final part of this journey, we leave behind the question of scale and move into something quieter, something more reflective, not about how large the universe is, but about what it means that it can be experienced at all. And as the vastness slowly settles into something softer, something more distant, you might begin to notice that the feeling it leaves behind is not just awe, but calm. If you're still here, still listening, you can leave it too in the comments. A small signal drifting quietly through the same vastness we've been exploring. And when you're ready, we'll move into the final part. As we move into this final part of the journey, something begins to soften. Not the scale of the universe that remains as vast as ever, but the way we hold it in our minds. Because after traveling from the Milky Way through clusters, across the cosmic web, and out to the limits of the observable universe, there is a quiet realization waiting here. There is no final edge, not in the way we might hope for, because the observable universe, that immense sphere stretching about 93 billion light-years across, is not a boundary of existence. It is only a boundary of visibility, a horizon defined by time, by the finite speed of light, by how long the universe has existed so far. Beyond that horizon, space does not suddenly stop. It simply continues, carrying galaxies, structures, and perhaps entire regions of reality that we will never be able to see. And this changes the meaning of distance. Because earlier, when we spoke about galaxies billions of light years away, they still felt connected to us. At least in principle. Their light could reach us. Their existence could be confirmed. But beyond the observable horizon, there may be galaxies whose light will never arrive. Not in billions of years, not ever. The expansion of space is carrying them away faster than light can bridge the gap. So there are parts of the universe that are, in a very real sense, permanently unreachable. And yet, they still exist. This is where the idea of infinity begins to quietly enter the conversation. Not as something dramatic or overwhelming, but as a gentle possibility. Because if the universe continues beyond what we can observe, and there is no evidence of a boundary, then it may extend indefinitely. It may not have an edge at all. And if that is true, then the observable universe, vast as it feels, becomes something else. A small window, a limited view into something much larger, perhaps infinitely larger. And within that window, the Milky Way becomes smaller still. Not just one galaxy among 2 trillion, but one galaxy within a region that itself may be only a tiny fraction of the whole. The scale we have been exploring, all the way from stars to superclusters, may represent only a thin slice of reality. But here is where something unexpected happens again. Because even if the universe is infinite, even if it extends beyond all measurement, our experience of it remains finite. Everything we can observe, think about, or imagine is contained within this one observable region. This one cosmic horizon becomes, in a sense, our entire universe, not because it is all that exists, but because it is all that can be known. And that gives it a quiet kind of completeness. Because within this finite view, there is still more than enough to overwhelm the mind. 2 trillion galaxies, hundreds of billions of stars in each, vast structures stretching across billions of light years. And within all of that, one small galaxy, containing a quiet planet, where this entire story is being considered. So the paradox deepens one last time. The universe may be infinite, but our experience of it is limited. The Milky Way may be insignificant in size, but it is central to everything we can know. And between those two ideas, something delicate begins to form. A balance between the infinite and the immediate, Because no matter how far the universe extends, no matter how many galaxies lie beyond our reach, the experience of it always returns here, to this single point of awareness, to this moment of observation. And that does not reduce the vastness. It gives it context, because without a point of view, scale has no meaning. Distance has no reference. Size becomes an abstract concept with no anchor. It is only through observation, through awareness, that the universe becomes something that can be described at all. So even as we acknowledge that the Milky Way is small, that it is one among countless galaxies, we also begin to see that it plays a unique role. Not because it is physically special, but because it is where the universe becomes visible to itself. And that realization leads us gently into the final layer of this journey. Because once we accept that the universe may have no edge, no center, no final structure, we are left with a quieter question, not about where we are, but about what it means to be here at all. And as that question begins to settle, slowly, softly, the vastness of the universe no longer feels overwhelming. It begins to feel still. As that stillness begins to settle in, something shifts again. But this time it is not about distance or structure. It is about time. Because while space stretches outward in ways that feel endless, time moves forward in only one direction, and the future of the universe carries its own quiet story, one that slowly reshapes everything we have explored so far. If we could drift forward far beyond the present moment of millions, then billions, then trillions of years into the future, the universe would begin to look very different. Not suddenly, not dramatically, but gradually, in a way that is almost impossible to notice from within a single lifetime. The changes would be slow, subtle, unfolding over timescales so vast that they feel more like a gentle fading than an event. At first, the familiar structures would still be there. The Milky Way, or whatever it has become after merging with Andromeda, would still glow with the light of countless stars. But over time, that light would begin to change. The bright, short-lived stars would burn out first, leaving behind longer-lived, dimmer stars. The sky would slowly shift from brilliant points of blue and white to softer shades of red and orange. Star formation itself would begin to slow. The clouds of gas that once gave birth to new stars would be gradually used up or dispersed. Without fresh material to form new stars, galaxies would begin to age. Not in a dramatic sense, but in a quiet, steady way. Fewer new stars, more aging ones. A slow transition from activity to stillness. And then, over even longer timescales, something else begins to happen. The expansion of the universe continues. Galaxies that are not gravitationally bound drift farther and farther apart. The light from distant galaxies becomes stretched, dimmed, and eventually disappears from view entirely. Not because those galaxies cease to exist, but because they move beyond the horizon of what can be observed. The observable universe itself begins to shrink, not in size, but in content. Fewer galaxies remain visible. The vast cosmic web we once described becomes less connected, more fragmented. Eventually, far in the future, the night sky from within our merged galaxy would look almost empty. No distant galaxies, no visible clusters, just the stars within our own local system. To any observers living in that time, the universe might appear small, isolated, perhaps even finite. They might not know that beyond their view, countless other galaxies still exist, forever out of reach. And this introduces a quiet twist to everything we've explored, because the understanding of the universe depends on when you observe it. Right now, we live in a time when the universe is still visible in its large-scale structure. We can see distant galaxies, map the cosmic web, trace the expansion of space. But this window is temporary. In the distant future, that information will no longer be available. The evidence of the larger universe will fade away. So the moment we exist in this brief slice of cosmic time is special in a very subtle way. Not because it is central, not because it is large, but because it is a moment when the universe can still be seen as a whole. And that realization brings a kind of quiet appreciation. Because everything we've explored, the Milky Way's place in the cosmic web, the scale of the observable universe, the possibility of infinity, all of it is accessible only within this narrow window of time. A few billion years earlier, and galaxies had not yet fully formed. A few billion years later, and many of them will have faded beyond view. So we exist in between, in a moment where the universe is both structured and visible, both vast and knowable. And that adds another layer to the paradox. Because while the Milky Way is not special in size, the moment in which it is being observed might be. A brief alignment of time, structure, and awareness, allowing the universe to be explored from within. And as we continue drifting forward, the future becomes quieter still. Stars fade, galaxies dim, black holes slowly evaporate over unimaginable spans of time. Energy spreads out more evenly. The universe moves toward a state of increasing uniformity, less contrast, less activity, less distinction between one region and another. Not an ending in the dramatic sense, but a gradual settling, a slow descent into stillness. And within that stillness, the structures we once used to define scale, galaxies, clusters, filaments, lose their sharpness. They become memories of a more active universe, traces of a time when complexity was more visible. So now, as we sit here, in this moment, surrounded by a universe that is still rich with structure, still filled with light, another quiet question begins to form. Not about how big the universe is, not about where we are within it, but about this moment itself. Why now, out of all possible times? As that question gently rises, why now, why this moment? It does not demand a precise answer. Instead, it invites a different kind of awareness. Because when we look at the universe across its full timeline, from its earliest moments to its distant future, this present era begins to feel like a narrow passage. A brief interval where complexity, structure, and awareness overlap in just the right way. In the very early universe, there was no Milky Way, no galaxies at all, only a hot, dense state gradually cooling and expanding. It took hundreds of millions of years before the first stars ignited, and even longer before galaxies began to take shape. Those early structures were small, unstable, constantly merging and evolving. There was light, but not yet the kind of organized structure that allows for long-term stability. And in the far future, as we've begun to see, that structure fades again. Stars exhaust their fuel. Galaxies drift apart. The universe becomes quieter, darker, more uniform. The intricate patterns of the cosmic web begin to dissolve into something simpler, less defined. So between those two extremes, there exists a middle era. An era where galaxies are mature but still active, where stars are abundant, where heavy elements exist in enough quantity to form planets, oceans, atmospheres, and perhaps something even more rare, awareness. And this is where we are, not at the beginning, not at the end, but somewhere in between. In a moment where the universe has had enough time to build complexity, but not so much time that it has begun to lose it again. And that gives this moment a quiet kind of rarity. Because even though the universe is vast, even though time stretches across unimaginable spans, the conditions that allow for this kind of experience may only exist during a relatively small fraction of that timeline. A brief window where everything aligns just enough for the universe to become something that can be observed from within. And this brings us back gently to the Milky Way, because earlier we saw it shrink from a vast galaxy to just one among trillions. But now, in this context, it becomes something else again. Not large in size, not central in position, but part of a specific moment in cosmic history. A moment where galaxies like this one are stable enough, rich enough, and quiet enough to support long-term processes. Processes that lead, eventually, to observation. So the Milky Way is not just a place in space. It is also a place in time. A structure that exists during a phase of the universe where complexity has reached a certain level, where stars have lived and died enough times to create the elements needed for planets, where environments can remain stable long enough for something more intricate to develop. And that realization softens the earlier paradox. Because while the Milky Way is not unique in size, it is part of a rare alignment of conditions. Not infinitely rare, perhaps not even uncommon on a cosmic scale, but still limited to certain eras, certain regions, certain circumstances. And that makes this moment feel quieter, less like a point of insignificance, and more like a brief opening, a window through which the universe can be experienced. And as we sit within that window, looking outward, tracing structures that stretch across billions of light years, something subtle begins to happen. The scale that once felt overwhelming begins to feel distant, not smaller, but softer. Because once you accept that there is no edge, no final boundary, no ultimate center, the need to place yourself within that structure begins to fade. The question shifts from "where am I in the universe?" to something gentler. I am here, and the universe is visible from here. And that is enough, not to explain everything, but to hold it, to let the vastness exist without needing to resolve it completely. And perhaps that is what this journey has been slowly leading toward. Not an answer, but a way of seeing. a way of allowing the Milky Way to be both large and small, both significant and insignificant, without needing to choose between those perspectives, because both are true, depending on how far you step back. And now, as we begin to approach the final moments of this exploration, the pace slows even further. The structures we've described, galaxies, clusters, filaments, begin to feel like distant shapes, fading gently into the background. And what remains is not their size, but their presence. A quiet awareness of being within something vast, something still unfolding, something that does not need to be fully understood to be experienced. And as that awareness settles, one final question drifts in softer than all the others. Not about the universe, but about you. If this moment is just a brief window in cosmic time, how would it feel to simply rest within it, without needing it to be anything more? And as that question gently lingers, how it would feel to simply rest within this moment, something begins to quiet down. Not the universe itself, because it continues endlessly expanding and evolving beyond anything we can follow, but the need to measure it. The need to compare, to define, to locate ourselves within its scale. Because at the beginning of this journey, everything was about size. The Milky Way felt enormous, almost infinite in its own right. Then, step by step, that sense of scale expanded outward. Galaxies became neighborhoods. Clusters became cities. Superclusters became vast continents of matter, and eventually, even those dissolved into a cosmic web stretching across distances that no longer felt tangible. And somewhere along that path, the Milky Way became small. But now, here at the quiet edge of that realization, something shifts again. Because small does not mean unimportant. It never did. It only felt that way when importance was tied to size, to position, to being at the center of something larger. But as we've seen, the universe does not offer a center. It does not assign importance based on scale. It simply unfolds layer by layer, without preference, without hierarchy. And within that unfolding, the Milky Way exists, not as the largest structure, not as the most central, but as a place where something rare has happened. A place where matter has arranged itself in such a way that it can pause, even briefly, and become aware of the vastness it is part of. And that awareness changes everything. Because without it, the universe would still exist, just as vast, just as complex, but it would remain unobserved, unfelt. The cosmic web would stretch across billions of light years, galaxies would form and merge, stars would ignite and fade, but there would be no perspective from which any of it is experienced. So the Milky Way becomes something more than just a galaxy. It becomes a point of experience, a quiet place where the universe is not just happening, but being noticed. And that does not make it larger. It makes it different, because now, instead of measuring the Milky Way against the universe, we begin to see that the universe, in a way, is being reflected through the Milky Way. Through this one location, this one moment, this one perspective. And that reflection does not need to be complete. It does not need to capture everything. It only needs to exist. And as that idea settles in, the vastness we've been exploring begins to feel less overwhelming. Not because it has changed, but because our relationship to it has softened. There is no longer a need to grasp it entirely, to understand every structure, to map every distance. Can simply be there, endless, quiet, unfolding. And within it, this small, temporary moment can exist just as naturally as the largest galaxy cluster or the longest cosmic filament. Because everything we have described, from the smallest star to the largest structure, shares something in common. It exists, for a time, within the same unfolding reality. And then it changes. The Milky Way will change. The stars within it will change. Even the structures beyond it will shift, stretch, and fade. But this moment, this brief intersection of awareness and universe, is happening now. And that is enough, not because it solves the mystery, but because it allows us to be present within it. So instead of asking how small we are, or how large the universe is, we can let those questions drift gently into the background. And what remains is something simpler, a quiet sense of being here, within a galaxy that is both vast and small, within a universe that is both knowable and infinite, within a moment that is both fleeting and complete. And as we approach the final segment of this journey, the pace slows even more. The ideas become softer, less defined, like distant stars fading into the background of a night sky. And what remains is not the scale, not the structure, but the feeling, a calm awareness, resting quietly within something much larger, without needing to reach its edges. And in that stillness, there is nothing left to solve, only something to gently experience. And now, as everything begins to slow, the journey itself starts to dissolve into something quieter, not an ending in the usual sense, but a gentle fading of questions. Because at the beginning, there was a sense of urgency, a need to understand, to measure, to locate ourselves within something so vast it almost felt overwhelming. The Milky Way was our starting point, something familiar, something that felt immense. And step by step, that certainty began to stretch outward into larger structures, deeper time, wider space, until even the idea of large began to lose its meaning. And now, here at the edge of that exploration, nothing has become smaller, but everything feels softer, because the universe has not changed. Only the way we hold it has. The Milky Way is still there, turning slowly, quietly, its stars moving in patterns that take hundreds of millions of years to complete. Our sun is still drifting along its orbit, carrying Earth through a region of space that feels still, even though it is in constant motion. Beyond that, galaxies continue to move, clusters continue to shift. The cosmic web continues to stretch across distances too large to fully imagine. All of it is still happening, but there is no longer a need to follow it to the end, because there is no end to reach. And that realization, instead of being unsettling, becomes calming, because it means there is nothing to finish, nothing to fully solve, only something to slowly experience. And as that settles in, the Milky Way returns, not as a measurement, not as one galaxy among trillions, but but as a place. A quiet, familiar place within the vastness. Not central, not special in size, but present, immediate, the place where this entire awareness unfolds. And that is enough, because even though the universe may be infinite, even though it may extend far beyond what we can ever observe, the experience of it always returns here, to this single moment, this single perspective, this one quiet point within a galaxy that, for now, feels like home. And perhaps that is the final shape of the paradox. The Milky Way is both insignificant and everything, insignificant in size when compared to the vastness beyond it. Everything, because it is where the universe becomes something that can be known. And those two ideas do not cancel each other out. They exist together, quietly, without conflict, because the universe does not ask us to choose between them. It simply allows both to be true. And as that understanding gently settles, the need to compare fades away. The need to define importance, to measure scale, to find a center, all of it becomes less urgent, because the universe does not organize itself around those ideas. It simply unfolds, and we, for a brief moment, unfold within it. So now, instead of reaching outward, the attention drifts inward again, not toward something smaller, but toward something closer. The awareness of being here, of existing within this vast, quiet structure, without needing to map it completely. The stars above, whether seen or imagined, are no longer just distant objects. They become part of a larger presence, something steady, something continuous, something that does not require constant explanation. And in that presence, there is a kind of rest, a feeling that the universe does not need to be understood all at once, that it can remain vast and still be peaceful, that it can remain mysterious and still feel familiar. And as that feeling deepens, the edges of the journey begin to fade completely. The questions soften. The scale dissolves into quiet, and what remains is something simple. You are here, in a galaxy that is both vast and small, in a universe that is both infinite and immediate, in a moment that is both fleeting and complete. And that moment right now is enough. So as you continue drifting, whether into sleep or simply into stillness, there is nothing left to follow, no further distance to cross, no final structure waiting to be revealed, only the quiet awareness of being part of something immeasurably large and gently at peace within it. If you're still here, still listening, you can leave a soft 3 in the comments, not as a task, but as a small signal that this journey reached you. And wherever you are, under whatever sky, in whatever part of this vast Milky Way, you are already exactly where you need to be.